Hello again. Today we're going to do section 6.3, arcs and angles. Specifically, inscribed angles is the main focus here. So, definition. Well, we did the definition earlier, but the inscribed angle theorem says the measure of an inscribed angle or of an angle inscribed in a circle. We're going to leave a lot more room that I left here. Is 1/2 the measure of its intercepted arc. Okay, and we actually did a question just like this in the 6.2 notes. It's just like doing number 5 in the 6.2 notes. But basically what you were given here is basically if you have this diagram, and I did label the vertices here, so you might want to do that. But if you have this diagram, then the measure of angle BDC is equal to 1/2 the measure of arc BC. So in other words, this angle here is going to be 1/2 the measure of its intercepted arc over here. And that's the inscribed angle theorem. Now, if we have time at the end, I'm going to go through the proof of that, but it is just like that number 5 in section 6.2. Okay, inscribed angles intercepting same arc theorems. That's a really wordy one. But basically here, you'll notice that angle 1 and angle 2 intercept the same arc. So if we're using the logic from the previous theorem, for example, let's say this is 80 degrees, this arc measure, then I would know that angle 1 would have to be 40 degrees. And because angle 2 intercepts the same exact arc, this is also 40 degrees, meaning that these angles are congruent. So it's pretty straightforward on why this works, but the actual theorems is inscribed angles that intercept the same arc. Are congruent. And I went through that example and talked you through why. Okay, angle inscribed in a semicircle. So here, what you want to look for here is the angle X here is inscribed in the circle. And as you can see, it's intercepting the circle here and here. And so its intercepted arc is this semicircle. Well, as we know, a semicircle has an arc measure of 180 degrees. So again, using that first theorem at the top of the page, we would know that this would have to be 90 degrees or 1/2 the intercepted arc. Okay, and this theorem simply states angles inscribed in a semicircle are right angles. Okay, the other thing you can look for is a diameter. A diameter is really helpful in these pictures. So if you see, and you can assume if there's a dot in the middle, that is the center. You see how this diameter or chord goes through the center. So that's going to be a diameter. And if the inscribed angle intercepts at the endpoints of a diameter, that is going to have to be a right angle. So that's another thing you can look for. Diameters are actually very helpful in these types of pictures. Okay, next, cyclic quadrilateral. So this is a quadrilateral. Inscribed in a circle. Just like this diagram here. So we have quadrilateral X, N, D, M here, and notice that all the vertices are on the circle, so that is inscribed in the circle. Okay, the next theorem is kind of cool. It says that the opposite angles of a cyclic quadrilateral are supplementary. And we're going to show why that is true here. So I'm just going to pick one set of opposite angles. So maybe I'll pick X and D. Let me use a highlighter. So angle X here intercepts at N and M. So it's inscribed in the circle, and then the intercepted arc would be this whole arc down here. Maybe I'll do that with a green pen to match. So it's from here all the way around to N. So that is for X, the angle X. Now, if I highlighted angle D also intercepts at N and M, and its intercepted arc is on the other side. So its intercepted arc would be from where this guy ends all the way around over here to there. So basically what happens here is the two intercepted arcs added together have a measure of 360 degrees. Okay, so it's 360 degrees total for the arc measures. And then using that theorem from the top of the page, we know that the inscribed angles are half. So in other words, the sum of the arcs is 360, so therefore the sum of the inscribed angles is 180. So what that does is prove that angle X and angle D would have to add up to 180, or in other words, would have to be supplementary. Okay, so that's an easy one to use as well. Next, you have the secant. So a secant is a line, so it's a type of line that intersects a circle at 2 points. So here I have this line cutting through the circle intersecting at B and at A. So that would be considered a secant. Now there is a difference between a chord and a secant. So a chord, for example, would be the segment AB, but a secant would be a line AB. So a secant goes on forever. A chord is a segment, and the points are going to be either on or inside the circle. Parallel lines, intercepted arcs theorem. So here, if we are given that these are parallel lines, and those are two secants, so parallel secants, then what you can say are that parallel lines intercept congruent arcs on a circle. Okay, this one's actually pretty easy to prove. So what I'm going to do first is just connect E and B. We do not know that this is a diameter. It doesn't have to be. But if you connect E to B and you know that these lines are parallel, then we have this Z. And remember, Z's tell us that alternate interior angles are congruent. Well, we also know from our very first theorem that if I have an inscribed angle, it's going to be half the intercepted arc. And then if I have this other inscribed angle that's congruent, it should intercept a congruent arc. So if you put numbers in there, it's fairly obvious. So let's say that this is 30 degrees and this is 30 degrees. Then the inscribed angle theorem says this has to be 60 degrees and that has to be 60 degrees, which implies those are congruent arcs. Okay, so the main reason why here is you can use alternate interior angles. And we know that those are congruent. Okay, so let's do some examples. So first of all, things you want to look for, these things are super helpful. Diameters in particular. So diameters cut the circle into two semicircles, or in other words, 180 degrees on each side. So on this number one, right away I see, again, you can assume if there's a point in the middle here, that is the center. So we have a diameter, BD. So right away, I'm going to say, well, if this is 80, I know this is 100, because this should be 180 degrees total. So always look for that kind of thing. The other things that you would know immediately from this diameter is that this is a right angle, and this is also a right angle. So those are things I would mark right away and look for those diameters. It's super helpful. Next, I would look for congruent inscribed angles. So maybe angles that are intercepting congruent arcs or intercepting the same arc. There's nothing obvious on this one for that. Congruent chords. Well, here are congruent chords. AD is congruent, segment AD is congruent to segment CD. So that means that congruent chords intersect with congruent arcs. So I right away know those are congruent arcs. So then I know this is 100. Okay, and then congruent arcs if you have anything like that. But these things are super helpful. After you've marked those things, it should be very obvious what the values of your variables are. So here, see how y intercepts 100, so that's going to be 50. And here, see how x intercepts 80, so that's going to be 40. Okay, next one. So I want you to pause and try these on your own, and then come back when you're done. Okay, welcome back. So here, I don't have a diameter, so that's not going to help me. So I'm going to look for congruent angles. Well, what I'm seeing here is this angle, 20-degree angle, intercepts ED, the arc, but also this one does. So I'm going to put a 20 right here, because that could be helpful. But also just using my inscribed angle theorem, I know that's going to be 40. So that's where I would start on this. Next, I have to use this 110 degrees at some point. And the Y here is indicating this entire angle, by the way. Well, notice where this intercepts. Intercepts here and here. So I'm looking at this whole arc. Well, that whole arc I know is 150 degrees. So therefore, Y is going to be 75 degrees. And as I said, X is 40. Okay, last one. Okay, looking for a diameter right here. So I know Y is going to be 90. Y is the whole entire angle. Okay, so that is 90. And then I'm noticing again, I have this 20 intercepting the same arc as the X. So X should be 20 as well. Just to be super clear, this intercepts the same exact arc as the X right here. So those angles would have to be congruent. Okay, good job. We'll see you next time.